And now, please welcome to the stage Oliver Turan with CTC and Lynn Allen, Technical Evangelist with Autodesk.
Thank you. Thank you.
Good morning.
Good morning.
Excellent. Well, hello and welcome to Midwest University. I'm grateful to be hosting this year's event with Lynn Allen. Lynn, I think you must have been coming to Midwest U. This is probably 4 or 5 years in a row. We certainly appreciate you joining us again.
Yeah, thanks. Appreciate the invitation. It has been, I think it's been about 5 years. I was kind of wondering actually how many years Midwest University has been going on.
It's been 7 or 8 now, I believe. Yep. And
I've been only invited for 5.
We'll make it up to you. We'll make it up.
Thanks for that. So I also am looking forward to a great event. I love coming to Midwest University. And this is an opportunity for us to meet you, our Autodesk customers, and to see some of the cutting edge things that you guys are doing. There are a lot of power users out there in the audience. I see a few of you that I know as well. In fact, we're going to see some amazing technology that you, our customers, have been doing right up here on the main stage. Some of you have been really pushing the limits of our software. And once again, as I mentioned, we're going to see some great examples of that. And I also want to comment that I don't know of any other event here in the US that is bigger than this event. This is a pretty amazing event with so many classes and so many people in attendance. I don't know of a bigger event like this for Autodesk products other than Autodesk University in Las Vegas. So I'm pretty excited about Midwest University. Commend you guys for doing this amazing event right here.
Thank you. That's nice of you to say, Lynn. Sure. Yeah, and indeed this event is a culmination of CTC and our partners, both Autodesk and our clients, getting together for mutual benefit. We at CTC view this event as a way for us to see what our clients are doing, what businesses and project issues you guys have, and how we can adjust our services and products moving forward to best suit where the industry is going. And to that effect, we're excited to have all of the speakers take time out of their work to join us. We have 10 different keynote speakers and 90 different breakout sessions over the next 2 days. And we appreciate the hard work that they put forth in preparing those sessions. So to our speakers, thank you very much. Let's give them a round of applause.
I was actually kind of looking at the classes on the app. How many of you guys downloaded the app? You guys have downloaded the app? All right, we'll show you how to do that later if you haven't done that yet. I was looking at some of the classes, great classes, right? Revit classes, Civil 3D classes, AutoCAD classes, BIM classes, all kinds of classes. Some of the classes are a little confusing to me. There's the one on herding cats. There's the one on, I don't know, to bend or not to bend. Does size matter? I'm not really sure what conference I'm at right now, to be honest. And then there's this one, how Autodesk gets MEP contractors to happy hour sooner. Is that a problem? Is that a problem? Where are my MEP folks? Is it a problem that we need to address? Is it? Okay, I'm gonna be there and I will bring drinks. I am here for you, okay? We're gonna help you out with that one. But some pretty amazing classes. I myself am also going to go to some of these great classes because they sound so fantastic.
Yeah. Absolutely, and we appreciate everybody presenting. And actually, to get us kicked off, we wanted to give the stage to HKS. HKS is both a client of CTC and of Autodesk, and recently they provided architecture, master planning, interior design, and branding services on our home of the Minnesota Vikings, US Bank Stadium.
Oh yeah, so do we have any Viking fans? Yeah? Yeah? Oh.
Unfortunately.
Hey, you guys started out great last year, right? You did. You started out, okay, wah. Anyway. There's always next year. Come on, you can do it, all right. So how many of you have been to the US Bank Stadium? Oh, all right, so I have not been there, but sounds fantastic. And presenting from HKS, we have Paul Ferrer. Paul is a conceptual designer with HKS-Line. He's focused on narrowing the gap between simulation models and the built environment. His current projects include environmental simulation, performance optimization via parametric modeling, VR, and aerial robotics. Okay, that all sounds pretty fantastic to me. And I recently found out that in order to prepare himself for presenting, he gets a little nervous. So to counteract that, he goes skydiving. Of course.
Burn up the adrenaline, I guess.
And now, I don't know, can't make that stuff up, right? So Paul, we very much look forward to your presentation, and let's all give him a nice warm welcome to Midwest University.
Thank you.
There you go, Paul.
Thanks. Hey, guys. Again, my name is Paul. I work for HKS in Dallas, Texas. And I wanted to say thank you very much to the organizers for having me here. I've not had the opportunity to attend this conference before, so I'm looking forward to the next couple days. HKS has made a name for itself over the last 80 years for being able to deliver very large and very complex projects. And over the course that we've been in business, the definition of what is a complex project is something that has been constantly changing and evolving. Starting out with the introduction of CAD and then moving into the world of BIM. And although the definition of BIM is, it's fairly open-ended, we find that at our office, we are gravitating towards a BIM workflow that uses Revit primarily. But the essence of that phrase, building information modeling, is something that we try very hard to keep in mind. How do we make use of all of this information at our disposal to not only document great buildings, but also design them in the first place? So I'm going to talk a little bit about how we approach that question at our office, and then show you guys some of the work that has been produced because of that. So within HKS, I work for a small team, and it goes by the name of LINE. It's an acronym. It stands for the Laboratory for Intensive Exploration. And we try to bridge the gaps that we see between our firm and the world of academia and then the industry as a whole. And we are effectively HKS's applied research and development team. We operate as a bit of a hybrid between a traditional architectural design team and then a consultancy. And in that sense, we spend about half of our time designing our own projects, and then the other half helping to solve very specialized problems for other teams within our office. And these problems can vary in complexity, everything from energy modeling and environmental simulation to complex geometry creation, and then getting into specialized applications development. And at that point, we're writing our own software when it's necessary. And the question that we get an awful lot is, why is that necessary? Like, why would you ever need to do those things? And indeed, most of the work that we do is capable of being built out of fairly regular construction assemblies. This is a project that I worked on a few years back, and this is the definition of a complex project. This is Fort Hood Replacement Hospital in Killeen, Texas, and it's roughly 1 million square feet. We had 30 or so subconsultants in it, and it took us like 4 to 5 years to finally get it off the ground, and it just opened recently. But this followed a workflow that was very repeatable, and after we got everything figured out, it was actually, it's actually quite efficient. And so this works great, and the only problem is that occasionally we like to design projects that look like this. And then that workflow is not quite as clear-cut as it was in the last project, and there's not like a whole lot of dimensionable things going on over here. What we have is a lot of very complicated geometry that's going to need to be very carefully communicated to the fabricator. And then we're going to have to figure out how to build this as a kit of repeatable elements so that it's not just astronomically expensive. So within HKS-Line, my role is that of a computational designer, and that means that I use computer programming to manipulate data during the design process. And that data sometimes is geometry, but it doesn't necessarily have to be geometry. And if you are building shapes that twist and curve like this, it makes sense to build them as a relationship of elements within the computer rather than as a fixed modeled object. So that way, as the design changes, you don't have to rebuild everything. But the real benefit of this type of workflow is not being able to make twisty, curvy shapes, although it is really fun, and we do it a lot. But the real benefit here is being able to make things talk to one another that might not have actually been able to do that before or never been designed to do that. So I'm going to focus on that primarily here. And so you guys are familiar with the new Vikings stadium. What you might not be as familiar with is the genesis of this one, and this actually started out looking a little bit different. It started out looking like this. And my team produced one of the initial concepts for the design phase, and it's actually cool. Some of the final elements made it all the way into the built project, the big rotating doors at the end zones, and then the ETFE clear panels, although they're being used as part of a structural clear story. But this project stands out in our mind just because of how fast we were able to do it. We did this entire thing, including the renderings and everything, in about 4 days. And it was by no means a perfect process, but we were able to define a very clear design direction and then add a very large amount of supporting detail quite quickly, purely through scripting. So everything here is being done in, this entire model is being built in Grasshopper. All of the elements here are basically being derived off of a series of 6 input curves that can control each one of these roof sweeps. And Grasshopper is a plugin for the Rhino 3D modeler. It's very similar to Dynamo in many respects. The coolest thing about this project to me was that those roof slices were not random. I mean, this was very deliberately produced in order to optimize the amount of natural daylight that was going to be falling on the playing field. We wanted this experience of playing football outside to be preserved, and we also wanted to make sure that we could block any direct glare from the players and for the fans. And so to do this, we hooked up the geometry of the model to a radiance-based daylight simulation. And this was the first time that we'd actually been able to do this on a project. You know, it's not uncommon to be able to build something and then simulate it, or build something and run an energy model on it. But to actually make use of that as part of the design, and as you change something, you get instant feedback. That was something that we've been trying to do for a while. And this is actually what excites me the most about the possibilities of computational design. It's what I specialize in within the Line group, and that is using the results of various simulations to iteratively influence how the design is going to finally progress. And so this video looks complicated, but it's actually a relatively simple way to explain how that works. So what we're doing here is I'm providing a series of simulations and then linking them to the creation of geometry to answer a question. So right now I've got a very small volume. I've given it the ability to rotate back and forth, add and remove windows and all the different facades, and then also mess with the shading on the outside. And then using something called a evolutionary solver, the computer looks at each frame of these simulations. We've got a useful daylight study and a solar radiation study, and useful daylight is described as daylight that's neither too bright nor too dark. And then for each option, it's going through and plotting the results up here in the left corner, and using an evolutionary solver, the computer can then start to understand which combinations of all of these parameters will go together to provide the best results. And you're in charge of defining what the best results actually are. So here I'm asking it to minimize the amount of radiation that's coming into the building, and then maximize the amount of daylight. And so, you know, it starts off bouncing around a little bit, but overall, it starts to gravitate towards a solution that is favoring northern light, and then shading and minimizing the amount of light that's coming in from the south and the west. And this is something that makes sense intuitively. We would try to do this on our own, but the computer's actually figuring it out mostly by itself with a little help from us. And so obviously this is answering just one question out of a nearly infinite number of questions that you could be asking while you're designing a project. But the takeaway is that we try to use the computer for what it's good at, which is crunching numbers repetitively over and over again. And that frees us up to think more holistically about the design. How can we make buildings that at a base level are more responsive and more sustainable? And so to see what that looks like on an actual built project, this is San Francisco International Airport. This is one that we're almost finished with. And we were brought in on the design side at the very early stages, and then after the project was secured, we became a consultant again. And here we were trying to figure out how to unify the workflow between the design architects and what ended up being a small army of sustainability engineers. As this is San Francisco, they're very interested in the sustainability of the project. And so what we were trying to do is look at every single design change that we would make to the geometry and then see how that would play out in the overall performance of the building. So this chart is showing how work would flow from HKS, the design architects, which were HKS and Woods Bagot, and then flow into our mechanical engineers and our sustainability engineers. And again, using Grasshopper as the intermediary between all of these different platforms, we were able to take each design option and then very quickly run a lifecycle analysis that's being depicted here, courtesy of Arup Engineering, and then also go through a conceptual level energy model as well as a passenger comfort evaluation. And then for things where we wanted to get into a little more specificity for certain systems, that's where those evolutionary solvers come in. And this one in particular is trying to figure out if the building can qualify for the LEED V4 daylight credit. And this is obviously a small area for demonstration, but what it's doing is it's choosing shading options, and it's running the series of LEED V4 daylight studies, which is spatial daylight autonomy and annual sunlight exposure, and then charting the results, again, finding out which ones will qualify. I'm also defining a couple things in the upper left-hand corner here that we're also trying to look at, which is bringing the shade area down to minimize the costs, and then also switching out various spectral profiles of the glazing so we can see how that impacts the quality of the daylight. And Lawrence Berkeley Laboratories out in California has a fantastic database of pretty much every glass type that you could ever run into in North America. And so we're testing out some of our favorites there. And the beauty of this is that you can start to, you can look at so many more options that you would normally have time for given a compressed schedule, and then you can take the options that meet both the aesthetic and the performance options that you're looking for, or performance criteria that you're looking for, and you can take them to the client with a very high degree of certainty that what you are providing is best for the scenario. This next project is Kuwait Children's Hospital. This is the only pediatric, or will be the only pediatric care center of this size in the Middle East. And it'll be one of the largest ones in the world when it's done. And while SFO was mainly focused on optimizing certain systems with analyses, with this one we wanted to use those same tools to provide more input in the design of the facade itself. One of the key design drivers for this project was that of a healing crystal, and you can see that language reflected in many areas of the interior and the exterior. And so we started with this crystalline triangular grid for the facade, and then developed a tetrahedral shading option and gave it the ability to twist and rotate with two goals. The first was to obviously respect the program underneath the shade, but then be able to provide a very clear view to the Persian Gulf, which is right outside the window. And the initial idea was to modulate the screen and the pattern very aggressively with the program changes. And that could look something like this, where we have a fixed number of pieces that are then kind of arrayed in patterns across the surface. But the client really gravitated towards an option that faceted sympathetically with the podium and ended up looking something like this. And so for each one of those macro facets that you can see here, we provided a tuned shading module that did both of those things. It reduced the amount of insulation on the surface, which in the desert is a big deal, and we're able to maintain as clear of a view to the Gulf as possible. We also looked at the feasibility and payback of renewables, in this case photovoltaic arrays, both standard as well as BIPV. And there is a chart that you can look at that will tell you the optimal orientation of a solar panel at any given point on the planet. But again, we used an evolutionary solver here to drill more specifically into our building and our context and start looking at things like row spacing, with rotation and building overshadowing, and making sure that it makes perfect financial sense to put these panels where they go, because they are quite expensive. And then at the end of the day, none of this really matters if you can't take all of that information that you've developed and studied and learned and apply it back to your final product, which as architects, usually that's a drawing set. And this project, because it was so large and spread out, we had teams working simultaneously on 3 continents at one point. We chose to use the Flux interoperability platform as a hub for all of our conceptual design information. So this is a screenshot of the Flux web interface, and we're creating all of our Grasshopper models and all of our simulations, and we're throwing them in here as a repository, and then we're able to pull out the stuff that we need and we want to go into the documentation model. And so here you're seeing that same series of points being brought in, and we're developing the adaptive components that are going to be making up the majority of the skin. In fact, 80% of this building is made of adaptive components that are automatically being generated off of that Grasshopper data. And the black window here in the middle is a Python scripting window. And the reason that we have that is the API of Revit is so large, it's massive. And Dynamo is still a relatively new way of looking at it. So oftentimes what we want to do with Dynamo is not actually set up to do that just yet. So we find that we're writing a lot of nodes to push and make that transition a lot more seamless. But at the end of the day is a fully functional Revit model that is then directly connected and linked back to our simulation information. And this is a fully connected workflow. So if someone makes a change in Grasshopper, it gets iteratively pushed into the Revit file, which is quite helpful because at the 11th hour of the 100% CD phase, I was still making pretty drastic changes to this facade based off of some new material information that we had on our simulations. And I would not have been able to do that. It would have been pencils down a lot earlier without this kind of workflow. So it helps in situations like that. And so, we've been speaking about documentation challenges, and we go back to the Viking Stadium again. This is actually the project that inspired a lot of the workflows that I've just gone over in the last few slides. Somewhere in the middle of the design process, we realized that, in the documentation process, we realized that some of the surfaces, of the macro surfaces of the stadium were actually curving in more than one direction. And this became apparent and became more of a problem as we tried to document the skin in Revit, because as you know, if you've used Revit, it really does not like twisting surfaces. So we went through several studies trying to reconcile putting a flat panel on a non-flat surface. And seeing if we, seeing how we could actually do that. So this is one of those studies. This is a growth algorithm that I wrote again in Grasshopper. And what this is doing is it's taking a fixed panel and then it's arraying it up the design surfaces, and it's trying to float the rotation and the tilt within the construction tolerances of the panel system, which I think in this case was like 1/8 of an inch or something, just to see if we could actually physically build it. And that produced something like this that we could use in our documentation model, but there were still some serious concerns about how we were going to build it. And thankfully, working together with Thornton Tomasetti Engineering and Mortenson, we were able to figure out how to get these mapped properly, and they did a fantastic job of applying all the panels in the field. I mean, it looks quite good. So after Vikings, the concept of rationalizing non-uniform geometries into repeatable parts was something that we took a big focus on, and it's a process that we use quite a bit. We're using it currently on the Los Angeles Rams' new football stadium, which unfortunately I'm not allowed to talk about today. We're also using it on this, and this is a development in Saudi Arabia at the Heart of Jeddah project. And each of these blue design surfaces is going to be made out of interlocking triangles. And right now in the design model, there's roughly 30 to 40,000 of them, and they're all completely different sizes. And so we we've developed a rationalization algorithm that goes through and tries to bring that down to a more manageable number. And in this case, we're able to go from that many thousands down to just 5 different shapes. And the process that makes that looks something like this. So we're now very firmly in the world of computer programming, and the goal here is to now create one piece of software that can obviously help with the design, but we're really trying to just skip the documentation process entirely and then take that file straight to fabrication and then start interfacing and writing G-code for the robots that are going to start building and machining all of these different parts. So to sum up everything, these projects are taking us in directions that we would not have anticipated before we started. And we found that the ability to remain flexible with our workflow is one of the most important things that we have going for us. And we like to remain platform agnostic, which is a phrase that I'm not sure who coined, but it's a really good one. You find something that works for 90% of the stuff that you do. And for most of the work that our office does, Revit is the only tool that we actually need. But there are some projects like these that need a little bit extra. And on these, we're writing completely new tools, mostly from the ground up, to get those concepts actually pushed into reality. Thanks.
Thanks, Paul.
Good job, thank you. Thanks. Wow, computational design. See, that's fantastic. Coming up with designs that you may have never come up with on your own. Pretty fascinating. Thank you so much. Now I really want to go to the stadium.
Yeah.
I totally want to go.
Paul's presentation made me realize how envious I am of architects and also how I could never be one at the same time. So, well, once again, thank you, Paul, for presenting. It was great to see your process and how you're using such tech to deliver projects, such as our wonderful new U.S. Bank Stadium. And we're somewhat staying within that project with our next presentation as well, but now from the contractor's perspective.
All right, so moving on to the construction phase. Our next presenter is Rick Kahn, and he's the Senior Director of Project Solutions from Mortenson Construction, and they, of course, are the general contractor on the U.S. Bank Stadium. Rick's focus is on enhancing today's project management processes with a very strong focus on operational innovation for the future of construction. He leads Mortenson's integrated delivery advancement team that's made up with over 60 VDC, virtual design and construction professionals that drive and support the use of tools and technologies on projects. And rumor has it, he's also an amazing surfer, of course, not here in Minnesota. And he's a great ukulele player too. I was trying to convince him he should play for us tonight.
Yeah, integrate that into your presentation if you can. Yeah.
We should have put that into his contract. But
Yeah.
anyway.
And I've had the pleasure to work with Rick for a few years now on a number of different projects. He and his team have helped us by giving us feedback and ideas to improve and expand our Revit Express tools for some of the processes that they have at Mortenson. We've also built some custom solutions around their use of BIM 360 Field, and we're currently doing some UAV drone flights on some current Mortenson projects as well. So as we welcome Rick to the stage, please direct your attention to the monitors as we have a short video to kind of kick off his presentation.
All right, thank you.
everyone. A little commercial to get you guys pumped up. It's an exciting project for our state of Minnesota, and it took over 8,600 people to design and build this project. So I'm telling just a small story of how we approach this complex project. A little bit about our company. Mortenson is a family-owned organization, 62 years strong, about 5,000 team members, and we do a diverse amount of projects. The things that get us going are the most complex projects. The more complex project it is, that's what we want to sink our teeth into. And the U.S. Bank Stadium was no small feat to accomplish. The project has some key challenging elements. The first thing was time. We had to build through 2 cold Minnesota winters. We had an existing facility that we had to work around. We had a lot of soil conditions. We had bedrock at different levels within the project. We also had some very unique, complex features of this project, including the world's largest operable doors on a facility, the largest ETFE roof system that Paul talked about a little bit before, a massive snow catch basin, which is insane, 50 feet deep at certain spots, 38-degree grading angle that we had to accommodate for. And of course, this massive truss system that was a unique challenge on its own. So you might think, like, what do we do to approach a problem like this when the design team has high expectations of delivering on the design intent, and our customer, the Sports Authority and the U.S. Vikings, the Minnesota Vikings, are hoping that we deliver on that promise? Well, it may sound super simplistic, but the reality is, the step one is building a plan. That plan is the key to how we are successfully delivering projects of this caliber. And that plan starts off way in the beginning of concept and iterates throughout time. So the image on your left shows the 4D image of the plan of 2015 built in 2013. And you see the image on your right, which shows the actual. Now, in a lot of cases, we had to really drive that critical path. So Mortenson was able to self-perform our concrete package, which was the key to driving the critical path in this job, to ensuring that all our trade partners, the folks that are really the experts to help us deliver this project on time. So this is an example of the day-to-day technology we're using. The 4D plan is not something we just use for business development. It's something that we use day-to-day. Our superintendents are driving this. There's over 100 iterations of this 4D model. This is the macro-level model. And you can see all the different scopes of work happening at the same time. For us, managing the flow of work is core to our success at any project. At one time, there was over 15 mobile cranes within a bowl that needed to be coordinated. We were assembling the massive truss system, the shoring systems, as well as maintaining multiple crews of concrete to ensure that this project gets built on time. So this is just one example of how we're using that technology. Again, it's not just a pretty picture and a cool animation. The superintendents are using this day to day. In terms of daily accountability, if you can't drive accountability to the plan, and if things get hard, and they always get hard, and they get tough, we don't abandon our plan. We just shore it up. But this is our pod meeting. It's a daily plan of the day meeting where we have all of our key trade partners, their soups, their foremans in, providing updates on their scope of work, holding them accountable and working with them to ensure that we give them the support they need, we remove the barriers, so this way they can execute work based on that plan. This is a meeting, Jason Brown and Dave Mansell, our key superintendents, kind of orchestrating this massive project. One team, lots of tech, one plan. Like Paul mentioned, being software agnostic is key. We get a lot of inputs, a tremendous amount of Autodesk products from AutoCAD, Revit, and Civil 3D, and all the other things as inputs from our design team. We also have a lot of our trade partners leveraging Autodesk products, or CATIA, like McGrath did, Tekla. So from Mortenson perspective, we have to be able to gather all those inputs, use a whole bunch of other technologies to ensure that we communicate that plan. So this is just a small sampling of some of the technology used. And unfortunately, I wasn't able to list out all the technology because it would be a couple of pages. But you can imagine at one point, I think we broke BIM 360 glue because the model was so massive. We had over 150 models within the federated model. So we pushed the boundaries of that, and we worked with the BIM 360 team to help us through that process. So it's been a good partnership, and TTC has been a great help as well. So overall, we like to say technology in everything we do. The reality is technology helps us visualize our work plan, and then we can simulate high-risk areas. That's really the core. The driver is to drive better informed decisions. It's all about ensuring that the teams can make the right decisions for the last planner, the last responsible person on the job site. So we use all kinds of technology, from mobile technology, cloud solutions, a ton of the Autodesk products, which has been a tremendous help for us, as well as a lot of others technologies. In the beginning of the project, obviously, we needed to understand the existing conditions, so we implemented reality capture, laser scanning, and a number of other technologies to capture the existing topography, the surrounding streets. So this way, we understand what the existing infrastructure would be so we can better plan our logistics. So this became a core to our starting point for developing our plan, understanding soil classifications and where bedrock was and how the massive foundation structures were going to tie into that. All played a role. In looking at concrete, again, concrete is the critical workflow. So we had to look at key areas. This image on the left is kind of misleading in terms of the scale of it, but this is a 10 by 10 concrete truss block that holds up the massive trusses on each side of the stadium. We had to model the rebar. We worked with our trade partner, Harris, to ensure that all the embeds were placed right. The embed that holds up that thrust block is the size of a Volkswagen. So it's a massive 3-ton, I believe, embed that needed to be coordinated down to the anchor bolts, making sure all the systems connect. These are the type of things that are happening in the back of house that no one really sees, but ensures that we can effectively build it. Looking at ways of breaking down the cranes, understanding how these cranes will fit inside the bowl, and how we're going to break them down, move them, and make sure they stayed out of the way of the logistics for assembling the massive shoring, and looking even at the detail modeling of the pivot point and the operable doors. All these things are happening on a daily, hourly basis. We had a team of about 6 Mortenson VDC people on that job on multiple scopes of work, working with our trade partners and our design partners to help ensure that this was constructible. And after we're done with our coordination process, since we self-perform that type of work, we are then taking that information and kind of dumbing it down into a digital 2D workflow. So this way our concrete crews know exactly what to build, how the systems are coordinated. We used Autodesk point layout a tremendous amount, understanding where the embeds were around these the concrete systems. We've always heard of the term 3D coordination and MEP coordination. We like to talk about total building coordination, because the purpose behind why we drive this, it's not just to make sure that things fit in the confined spaces and the closed spaces, but really making sure the design intent is met by the construction process. So tying into the audio, visual, the entertainment systems, making all these things operable. And that's our goal in terms of 3D coordination. It's not to fit, it's to make sure it's maintainable and operable. And that, again, was a tremendous effort from our trade partners and our team. And of course, the enclosure. It's a beautiful enclosure. It's a fantastic facade. There was a tremendous amount of detailing that went through. Paul touched on it a little bit. Because of the way the angular enclosure was built, we actually had to work with McGrath, the enclosure contractor, to understand the profiles. So this way we can connect the primary and secondary steel to the enclosure panels to ensure that we maintain that complex structure. And these are just some of the types of modeling that we're doing. We're looking at taking the design information and looking at the beautiful detailing in 2D and trying to create a model that represents that at a real scale. So this way we ensure that the foldings and the fastening systems and all the interfaces with water barriers and vapor barriers are being met in the detailing process. And this is what we give to our teams to then go and build. Our models were pretty complex, and it was the federated model, like I said, it was about 150 different models that made up the overall process. But the goal is to visually communicate, so this way we can execute right the first time. In the end of the day, we're just visualizing to communicate. The idea behind the visualization is to help us better communicate, which drives better collaboration within the team, which leads to the better informed decisions. Again, getting the last planner to be able to make the right decision at the right time as this project evolves is key to that process. So in finishing up, I just wanted to show a quick video in terms of how our team looked at this project from a planning perspective.
When you win a project of this size and complexity, where do you start? You have to start with a plan.
We spend more time planning, which equates to less time building. We utilize the most advanced tools in the industry, implement lean planning strategies, leverage our sports expertise, and hire the best people.
Mortenson, with the technology they have and the way that they're able to show the job as it's going, makes it easier for every sub. You have a plan, and it's a pretty set plan. It makes everybody's job just much easier. The job gets done in time, people are safe. With the planning so far in advance, I mean a year in advance, we're able to plan for overhead, equipment, and everything else based on using that technology.
Created by adding the element of time to a 3D model, the 4D model allows us to simulate hundreds of solutions and optimize the plan to create the best plan. It helps us visually communicate our plan to our trade partners and better collaborate and execute that plan.
The amount of technology that was used on this project, down to the day on every task, was quite the process and done very well. And having the up-to-date drawings at everybody's fingertips was very important, and it was very easy with the technology that was used, from the submittal exchange even to the punch list. Everything was digitalized and easy to pass along. With all the different trades, it could be very easy to get documents lost. They did a very good job with all the technology that was available to maximize that process.
Without 4D technology, construction would have taken a lot longer. Costs would have been accelerated. Mortenson had committed to using these personnel who were familiar with this technology, and we ended up having the building before we even anticipated getting it.
Virtual reality technology gives us and our customers the ability to visualize completed spaces before any construction has begun. This is a critical tool to make informed decisions while saving time and money and creating the best possible solution.
In addition, lean construction and quality prefabrication of materials advance the schedule more so than traditional building practices. Our ability to identify opportunities to prefabricate materials and produce project components off-site absolutely deliver this project faster and with the high quality we require.
These tools, in conjunction with a comprehensive plan, are the reasons we were able to build the US Bank Stadium in a way that delivered the best value for taxpayers and the Vikings, while creating an iconic building resulting in early and under budget completion.
So redefining what's possible. We like to say we don't compete with our peers in the industry. We compete to what is possible. And that's what drives us. And it took a Herculean effort. Like I said, over 8,600 people to design and build this project. To deliver this project 6 weeks early, $6 million under budget, and at zero punch list on opening day. That is unheard of in the sports business. But we weren't able to do that without the partnership that we have with our design partners and our trade partners to be able to deliver this project at this level. So with that, I'd like to finish by saying I could spend an hour talking about this project. There's so much to talk about, but the reality is we have a lot of information on our website, so please take a look at it. And hopefully I'll see you throughout the day, so please feel free to ask me any questions. Thank you.
Thanks, Rick.
Thank you. Wow, early and under budget. That always happens.
They can build football stadiums. I wonder if they could help out with the offensive line.
Now I really want to go to that.
But yeah, that was excellent, Rick.
That's amazing.
Yeah,
That
we
was
appreciate that
amazing.
inside look at your processes. It's certainly a challenging project with lots of risk. Awesome to see how you guys pulled it off, delivering it under budget and ahead of schedule. Our next presenter is from ISG. They're a multidisciplinary firm with 230 employees, 8 offices across the Midwest. And we asked them specifically to present on virtual desktop infrastructure, as we see this as a growing need among our client base as projects and firms are requiring to work more collaboratively from any location.
Right, right. And I mean, how many of you come from the IT side of things? Or my IT folks? Are you just afraid to admit it? Or... No? No one's gonna raise their hands? No? Some of you? I know there's gotta be a few of you. Okay, all right, okay. So we all know the value of a great IT department. We certainly know what happens when we do not have a great IT department, right? And as we work more and more with different types of software, and we have more variables that we throw into the mix, such as remote users or working with dispersed project teams, and of course now that we have the cloud, a great IT department is more important than ever. So next up, we have Eric Eby, and he's going to present, as was mentioned, from ISG. Eric is their Director of Information Technology. And his expertise is in networking, it's in virtualization, operating systems, and then the wide variety of software that is used at ISG to ensure that their end users are able to complete their work efficiently and hassle-free. Imagine that, wouldn't that be fabulous? And I also heard that in his spare time, when he gets done doing a great job in the IT department, he gets to hop on his Harley and ride around.
Sounds pretty awesome.
Sounds pretty awesome.
Well, Eric, we look forward to your presentation. And as we welcome Eric to the stage, please direct your attention again to the monitors.
At ISG, we've built our firm on ingenuity, innovation, and virtualization that has fueled projects across the nation. Through integration with virtual software and desktops to Autodesk, ISG has helped support efficient architecture, engineering, environmental, and planning solutions that have positively impacted communities and clients for the past 44 years.
Hi, I'm Chad Surfront. I'm president of ISG. We look at technology as a way to differentiate ourselves. Historically, we've utilized technology to stay in front of things, be able to deliver our designs in a better fashion. And then over the last probably 5 years or so, it's been a huge transformational time for us. The way we've been able to use our VMware has changed our way of delivery from something that was at one time more of a geographic-centric focus, and now we've actually changed our company so much more to a client-centric focus. By utilizing VM, we can be doing our work absolutely anywhere throughout the world.
Looking for ways to intimately connect clients to their projects, ISG has worked to instill a culture that promotes collaboration and flexibility, which translates into better results.
ISG strives to not only continually push for success from our professionals, but also have technology that supports such efforts. We want to empower employees with an accessible and reliable solution that meets the demand for flexibility in today's workforce. VDI gives our employees the ability to run their work desktop on any device from any location.
The future possibilities in the A&E industry and technology to support such services are endless. Through intentional and strategic engagement, ISG will continue to push boundaries and empower professionals that will turn visions into reality.
Good morning. Welcome. I'm Eric Eby, Director of Information Technology at ISG. And I was asked to talk about VDI and virtual desktops and how ISG successfully runs VDI in an Autodesk environment. So virtualization. In virtualization, we've all heard the term, whether that be cloud computing, as mentioned earlier, companies like VMware, Microsoft Hyper-V, Citrix.
Virtualization at its core is simply running multiple servers or desktops on a single hardware host. VDI, or virtual desktop infrastructure, is exactly that. It's running your work desktop virtualized on a server that sits in a data center, whether that be on-premise or in the cloud. It's become mainstream in the last 5 years, and just within the last 3, they've introduced dedicated graphics. And that's what really allows us to run Autodesk products. This allows users to connect to a work desktop from phones, tablets, Macs, Windows PCs, or simply inside of a web browser. Anytime, anywhere in the world, with the only requirement being an internet connection. It sounds too good to be true, right? Well, it's not. ISG has actually been running VDI successfully for the last 2 years. So how do we tackle graphics requirements for Autodesk and VDI? It seems to kind of be the major concern, and the biggest issue is you can get that in one of 2 ways. The first way, and the way that ISG currently runs it, is through vGPU, which stands for Virtual Graphics Processing Unit, using NVIDIA grid cards. The first generation cards were their Kepler series, K1 and K2 cards. ISG currently uses their K1 cards. And then most recently, I think within the last 6 months, maybe a little bit longer, they've released their Tesla series cards, and that's Grid 2.0. Just to give you an example, a single Civil 3D host at ISG, we can fit 16 users per server, and Revit host, we can fit 64. We currently run Dell R730s, and we can fit 2 of these graphics cards in each server. The second way of going about that and getting that solution is called MXGPU, or Multiple Graphics Processing Unit. Same concept, it's just AMD's solution to compete with NVIDIA. Theirs is a lot newer. I think the FirePro S card series was just recently released 4 or 6 months. Don't quote me on that, but we are currently testing this in our data center. I do not have one in production yet. But so far, things have been promising, and we hope to implement the AMD card here within the coming months. So why? Why would anybody want to do this? Well, first and foremost, and the biggest reason, is flexibility. It allows users to connect to their virtual desktop from anywhere. Any location that has an internet connection, you can connect to your work desktop. The opportunities are endless. I mean, if you're snowed in, you work from home. If you're traveling, connect in the car or at a hotel. You get the same work desktop regardless of your location. The second reason is scalability. It gives IT the ability to scale your desktop up or down. For example, if your desktop has 16 gig of RAM and you're working on a really large Civil 3D model and you need 32 gig of RAM, we simply shut down the virtual desktop and within a few minutes start it back up and you have 32 gig of RAM. The same goes with hard drive space, CPU, etc. Thirdly, and one of the main reasons ISG moved, is centralized data. This allows everything to be in a single data center, and your virtual desktops are fully connected to the servers they're accessing. We had major issues, and I'm sure you guys can think of how often do you open a client model that might be located at a different location. With our 8 locations, if someone at our Faribault office was opening a file that might have been on our Minneapolis server, it may have taken 15 to 20 minutes to load or save that file. By accessing and utilizing VDI, we don't have to worry about that. Everything's located in the same spot, and it just makes IT's job and everything much easier. So how did ISG succeed? I hear horror stories of other A&E firms and other companies attempting to implement VDI only to revert back because performance was maybe not what they expected. Where did they go wrong? I can't really say for certain. What I can tell you is what we did right, and I usually break that down into 3 different phases. And the first one is storage. Storage is the heart of it all. When we first implemented storage, we had major issues with our SAN. It ended up being under-spec'd. We increased the controller to gain better performance, and it did solve the majority of our issues. In the end, though, the performance we were looking for was found in solid-state drives. Currently at ISG, all of our virtual desktops run on local solid-state drives in each host. Anybody in IT might ask, well, what's the difference between doing that and something like a solid-state all-flash SAN? I tried purposely not to get too technical in this presentation, but if you have those kind of questions, I'll be around. I'm more than happy to answer those. The second reason is our backbone. We invested heavily in a 10 gig core. I feel 10 gig network connectivity in a VDI environment is very important. To give you an example, if you run a physical desktop running Civil 3D in an office, you're accessing the server at 1 gig speeds. Currently, anything above that is not really supported. So it's highly recommended, and obviously with the virtual desktops being able to access the servers at 10 gig speeds, you gain faster speeds for opening, saving, or interacting with anything that resides on that server. And lastly is WAN. We were fiber focused. We invested heavily in fiber at all 8 of our locations, including implementing an SD-WAN. We found that anything less than fiber just was not stable in our environment. We had 2 locations where we did test coax cable internet. I think we went up to speeds up to 125 meg where they were supported, and it just didn't run. It ran, it just wasn't stable. So fiber was what we focused on, and that's really been a game changer for us. So what's the future outlook for virtual desktops? Obviously, virtual desktops from here are only going to get better. Recently, protocols such as VMware Blast Extreme are lowering bandwidth requirements, and they're always releasing new features. This type of setup embraces the work from home movement. Obviously, I think even at ISG, we have space as a hot commodity. You know, if you hire new people and you don't know where they're going to sit, VDI makes things very flexible in the sense that they could sit in a floater station, they can take a floater laptop, conference room, etc. And lastly, it allows companies to hire the best talent in any time zone. And I think that's a pretty cool reason to look into it. People who embrace that work from home or work remote and that they have that culture to support it, it's pretty cool to be able to hire anybody in any time zone and have them work in your environment. So if you're interested and this really intrigues you and you want to learn more, my colleagues Jason Douglas and Jamie Steinborn are hosting a class, 903, running Civil 3D in a VM environment. They'll be actually running a live demo on the ISG network connected to the hotel internet here. So if you're interested, you can certainly see that. They'll also run through certain configurations that might have been different in a VM environment that they saw that was different than running it in a physical environment. Just what we've seen, what worked for us, what hasn't, and just overall how we've been able to run that. I will be attending that class, so if anybody has any questions, feel free to jump in and ask me anything you like. Otherwise, that's all I have for you guys today, short and sweet. Thank you for your time, and I hope you enjoy the event.
Yeah. Thank you. We all want to work from home, right? Yeah?
Yeah, sign me up.
Sounds good to me.
But yeah, that was certainly a timely topic, and we appreciate you sharing that, Eric. Moving on to our next presenter, a staple and a highlight of prior Midwest University events is our presentations by our partner Autodesk. It's at substantial cost that they work with us to offset expenses to help keep attendance costs low, and they also provide a number of technical resources in addition to our following keynote speakers. In past years, we've asked Autodesk to provide their vision for our industry, and over the past 2 Midwest U events, they've shown that vision, which they call the future of making things. This year, we've asked them to focus on not only what is happening, but how Autodesk is rising to the challenges of our industry.
That's right. And so I especially appreciate this opportunity to introduce at least one of our Autodesk presenters today, Angi Izzi. And Angi and I actually work on the same team at Autodesk. And she presented here at the general session a couple of years ago. Some of you might remember her. up here on the main stage. And I actually met her about 5 years ago at Disney. I was doing a presentation at Disney, and she offered to join, and I was incredibly impressed with her knowledge of the AEC industry, and she still continues to impress me every time I spend time with her. She has a vast amount of knowledge of facts and figures that is constantly stunning me. We were just discussing that last night when she was spewing out all kinds of facts and figures. Anyway, so I specifically am looking forward to hearing what she has to present on today, and I'm sure that you're in for a real treat.
Yep.
And
it's also my pleasure to introduce Ken Manoff. Saeed and I work with Ken and his group to ensure that we at CTC align our resources and efforts and invest wisely in different processes, tools, and services that will have the greatest positive impact for our customers. Ken is the Senior Director for North American Channel Sales. And thank you, Ken, for making the trip and presenting for us today. Ken and Angie, you have our attention.
come on up.
We'll invite Ken up first.
A nice round of applause. Thanks.
Thanks, Oliver. Good morning, everybody. Hope you can hear me well. Thank you. So Angie and I are very excited to present to you this morning. So as mentioned, I'm Ken Manoff, and I get the great pleasure of working with our channel partners all across the Americas. Before we get started, though, I want to take a second and recognize our long-term partner, CTC. Not only is CTC a long-term partner of Autodesk, but our relationship is built on trust, alignment, and success. Success not only with their business with Autodesk, of course, but more importantly is the success with each and every one of you in this audience. So a big shout out and thank you to our partner, CTC. Thank you. So let's go ahead and talk about entering the era of connection. And we've talked about our individual workflow solutions advantage for several years, the depth and breadth across the life cycle for building and infrastructure projects. But now the I in BIM is more powerful than ever. Information is everywhere. Sensors are everywhere. And now everything can be geolocated. We are able to connect our solutions like never before. So let's take a look back so that we can better understand where we are headed. Pretty cool video, huh? So more than 30 years ago, as we all know, Autodesk software helped shift work from the drafting table to the computer with AutoCAD software. We call this the era of documentation. We help designers, engineers, and contractors leverage digital technology to transition from error-prone and inefficient manual processes. And I think we all know that DWG became the standard in the industry. And then digital modeling technology ushered in the era of optimization, along with building information modeling, or BIM as we certainly know it. When we moved from 2D to 3D, Autodesk invested strongly to help the industry transition to BIM. And we are still doing that today with products and workflows that help visualize, simulate, and analyze all of our designs before we break ground. It is probably worth mentioning, actually definitely worth mentioning, that we acquired Revit 15 years ago today. Isn't that amazing? How time flies, 15 years ago. And of course, the results are clear, as you can see on the screen. Many of you have experienced similar types of results by adopting BIM. And BIM adoption is rapidly accelerating around the globe. Increasingly, owners and governments are mandating the use of BIM to significantly reduce waste on public projects, and they're mandating it as part of the constructor sector transformation, cost-saving efforts, and even in the end, climate change mitigation strategies. BIM is here to stay and only getting stronger. And now we enter the era of connection. It's a new opportunity. for builders, designers, engineers, and owner-operators. One where the digitalization, the power of the cloud, and big data are changing everything. Where the boundaries between planning, designing, and building are disappearing. Digitalization and access to the cloud will drive this. The cloud lets AEC teams organize themselves, manage information, and execute processes across distributed environments. So before we talk about Autodesk-specific efforts, let's look at how technology is changing everything around us. It's changing how we buy glasses, for example, clothing, music, and even recently, I received a gift certificate for a pair of earbuds, a custom-made set of earbuds, where they said, download an app. I did that, and through the app, I took a picture of both of my ears, and the company was able to understand the sizing and the shape of my ears. I guess they're a bit awkward, I don't know, and build me a custom set of earbuds. And boy, by the way, they fit amazing. And all through that experience, they sent it to me. This is what the world is all about today. This is a great example of connecting the digital and physical worlds. And everywhere we look, everyone is looking to disrupt status quo. Status quo is no longer where we should be. Any companies that are thinking of holding on to what they do today, those are the companies we see falling behind. So what I would like to do is share some of the trends that are shaping our strategy and direction with you. So the first trend is higher definition surveying. And we all know that current surveying methodology remains one of the major reasons why projects are delayed and go over budget. New technologies such as Autodesk Recap Pro that integrate high definition photography, 3D laser scanning, and GIS can dramatically improve accuracy and speed. This is another example of connecting digital and physical. This is the Glen Canyon Dam, one of the largest man-made reservoirs, and it's a vital defense against severe droughts. This model will support education programs for operations and maintenance for years to come. The second trend is around machine learning. Machine learning is a type of artificial intelligence that provides computers with the ability to learn without being programmed. Imagine if you feed these programs with past project information, what we can do. This is a layout of our new Autodesk Toronto office. Of course, we did surveys of the employees, identifying work requirements and preferences up front. We also had to understand our design goals for increased productivity and collaboration. We then used generative design to lay out alternative designs and optimize for the best outcome. This learning will allow us to enhance our software that you already use today. And by the way, we ended up with a pretty cool office. The third trend is around digital visualization and was mentioned earlier. Virtual reality is being adopted at an impressive speed. You've seen many phones that include headsets just in the last year. This is becoming a reality within the AEC segment as well. Let's see an example. Imagine yourself immersing yourself in a coffee shop well before any construction begins, understanding experiences, lighting, layout, product placement, and much more. The accuracy and level of detail has definitely come a long way making this usable. Even being able to provide field workers with a visual tool. Kind of makes me want to get a cup of coffee. And the last trend that I want to talk about is around future-proofing design and construction. I'm excited about this, that we're entering a really new, interesting era where manufacturing and construction processes are merging. We see an increased use of prefabrication and robotics. Autodesk is ideally positioned to lead the way in this new industrialization of construction. I like this topic so much because I have a manufacturing background. Not very popular in this room, but that's fine. and so I wanted to share a couple of examples of this trend. So this is Redpoint. It's an app designed to increase safety on the job site. Imagine if you could outline an area on a mobile device and then equip workers with a censored vest that not only alerts the foreman, but the workers when entering unsafe areas. This is another great example of connecting the digital and physical worlds together. Think of the possibilities. Pretty cool. Also, 3D printing technology has shown great promise as long as I can remember, but now it becomes reality. Fast brick robotics is pioneering innovation in construction, bringing this same technology on a larger scale, obviously, to construction. Think of the quality, the cost savings, the benefits of such technology in the construction site. I think it's pretty amazing. Who would have dreamt that 3D printing technology could have gone to this level? Fast brick robotics. What are the possibilities? Really cool. So Autodesk is at the intersection of the need for more buildings and infrastructure, and at the same time, the democratization of the technology. We are taking the lead in making these digital technologies relevant and valuable for our customers. Now I'd like to turn this over to my colleague, Angi Izzi, who's going to show you what the era of connection means to our current product strategy as it relates to collaboration. Angi? Thank you.
Thanks, Ken. Lynn, this is only my second invite to Midwest U, so hopefully I'll get a couple more invites in the future. Love being here in the Midwest. Thanks again for having me here. Really excited to show you some exciting technology today. We are really looking at the era of connection as a way of getting into connected BIM. I'm going to talk to you a little bit about how we're talking about collaboration in the future. As traditional silos disappear, BIM's going to provide a foundation for success for all of you. As you saw today earlier, BIM was part of the success for this stadium project. And this is really about enabling the entire life cycle for design, build, and operate to seamlessly be connected. But what does connected BIM mean? It's not a product. It's not a process. It's really simply describing the potential value of BIM in tightly interconnected workflows, spanning design, build, and own processes for buildings and infrastructure. It really is enabling Autodesk to help provide you software to do that. So BIM is the power of the cloud. It really allows us to look at a couple of things. We look at insight, really being able to have bidirectional information, like the coffee shop, for instance, providing insight of the coffee shop, being able to see what's going on, what the building's going to look like. Really enable continuity, the continuity of real-time access, understanding what in a common place what the most up-to-date design is. And then collaboration. Collaboration being able to, in the mobile world that we live in, really being able to have anytime access to that information.
Imagine a design project so complex that it requires dozens of stakeholder groups from across the globe to deliver it. And imagine them collaborating seamlessly to deliver a world-class building ahead of schedule and under budget, regardless of location, discipline, or software tool sets. Imagine them working together in a single project ecosystem, planning, designing, building, solving challenges, and making swift decisions based on deep insight. driving up profitability, driving down coordination issues. Welcome to the future of project delivery. Autodesk is transforming the way we work by developing an entirely new system for the BIM project lifecycle, from design through construction. This platform unifies everyone in a common data environment, building owners to architects, engineers to general contractors, eliminating the complexities of today's project collaboration process. Gone will be a lack of insight due to companies working in design and data silos. Gone will be incompatibility concerns like unique software toolsets, different IT stacks, or inefficient handoffs that hinder collaboration and slow momentum. And gone will be the headaches of working with multiple global teams and relying on phones, file servers, and emails to communicate. This is the Autodesk Cloud made fluent in BIM. Beyond a place to simply store or share files, it will be the foundation for how teams deliver projects. Here will be a single project environment where design and construction teams will collaborate, design, review, and build as if in a single location. Here, insights into clashes, model changes, and quality control are easily accessible. Here, independent systems and toolsets work as one. Here, the design and construction teams are connected, with project documentation available in real time to those in the field. And here, all stakeholders are provided access to the right version of the right data in the right context and on the right device. When it comes to delivering projects, it is often the process that defines the success of the project. Welcome to a better process. Welcome to the future of project delivery.
Pretty inspiring, huh? This really excites me. It makes me really proud to be working on this project. So we want to talk a little bit about the trends that are driving this, the trends around project delivery. It really is around owners realizing the BIM mandates that are coming from owners today, and then understanding the greater project savings and the advancement of new standards. This is really important for driving the success for project delivery. The other thing is designs are optimized. There's this high frequency of information that comes across the projects. You notice that in the stadium project, the information, especially on the generative design area, really have to be able to manage that information. And then the third thing is really around the distributed teams. It really is a great idea to be able to use the distributed talent from anywhere that they possibly can be across the world. And this is really driving this project delivery mechanism that we're putting together. So let's take a step back for a moment and let's talk about how our customers deliver projects today. There's this massive amount of coordination that takes place, risk mitigation that takes place on all these projects. And we really need to understand how they go from design to documentation to construction handover and be able to use all that information to have the most up-to-date information, really around data management. And our portfolio today supports a lot of these projects during the phases of these projects. So let's start our established tools really are around some certain tools that we've created for construction. Let's kind of start looking at these first. You heard a little bit about them from Mortenson today. Glue, field, layout. These are really around digitizing the construction site. And last year, we brought Autodesk Docs, we brought BIM 360 Docs to the field, really allowing construction documentation management. Moving to the top, we actually have all these world-class solutions that we've had for authoring tools for many years, and now we're starting to connect them together in new, meaningful ways. And last year, we brought you BIM 360 Team as a way of connecting teams with Collaboration for Revit. And Collaboration for Revit has really been the best-in-class cloud solution for allowing teams to collaborate together. I'm here today to make a big announcement. The big announcement is BIM 360 is going to become our common data layer. It becomes our new brand for design, build, and operate, not just the construction tools. So this is really around allowing customers to really have align around the design, build, and operate of a building. But that's not it. This all has to be in one common data environment. And we really, I shared with you that we have, made this brand, the BIM 360 brand is really our common data layer. But it really is not done. We're not done yet, because right now we kind of have a bifurcated stack. We have two separate offerings. We have the BIM 360 team and the docs. I'm here today to tell you that we're combining these. This year they will become a unified stack. This will be a common data environment for designers, owners, and operators and construction to come to one place to work. This is very exciting for us. I really wanted to come and show you kind of a product teaser. So imagine you can be in one model, in one interface, and be able to navigate through hundreds of PDFs, as you see across the bottom of the screen. Navigating in a hypermodel way and delivering project information the way teams think, in different scopes of detail and in for different scopes of work. Imagine eliminating silos and improving coordination, really enabling customers clearly to reduce friction, deliver a virtual co-location experience, and enable deeper insight into the project. That's what we're providing. That's what BIM 360 will become. So before I leave, I just want to make sure I make one point. Today in market, we have BIM 360 team and collaboration for Revit for design teams. Really important that you start moving to this technology, because we're taking this further this year. This is not a new product we're offering. We're just enhancing our existing products. BIM 360 Docs is really our construction data management solution, really around coordinating controlled construction document access. So my biggest message for you today is trust the cloud, trust Autodesk Cloud, and bring your projects here to communicate and coordinate. Thank you so much.
Thank you.
Well, that's excellent news.
Excellent.
Docs and team merging. I'm excited for that, for multiple reasons that I'll express later. But that's awesome.
Yeah.
One of the things that we started doing a few years ago is we started partnering up with charities around Midwest University. And this year we partnered with Sharing and Caring Hands, which is a local charity in Minneapolis. And you might have seen a couple different mentions of this perhaps on the website. For instance, when you registered, you had the option of getting a tablet or taking those funds and donating it along to Sharing and Caring Hands. And we also ran another promotion where if you registered from a certain date to a certain date, CTC would contribute an amount based upon your registration between those dates as well. So we want to show you that those funds are going to good use, and there's actually a short video prepared by the charity to kind of show you how those funds are being used, and we appreciate you guys not only coming to Midwest University, but also helping us give back to the community in this way as well. So we'll enjoy the short video, and then we'll dismiss you to your morning classes.
It's all about serving others. It's all about loving. It's all about being kind. As long as we as individuals make a difference in the world, no matter what religion, what color, love doesn't know any color.
Located in the heart of Minneapolis, staff and volunteers at Sharing and Caring Hands have opened their hearts and their doors to the poor and homeless since 1985.
You're doing a fabulous job.
Hundreds of volunteers offer thousands of meals every year. Families also find emergency housing here.
This right here is a blessing.
And so much more.
So we have a food shelf, we have a clothing shelf, we also have a medical clinic that people can come to if they don't have insurance. One of the big things I've seen is the dental clinics, where people have an infection or they need to get a tooth pulled and it's very painful. They can come here and they can get that done for free.
Put quite simply, Sharing and Caring Hands is the place that does what other shelters either can't do or choose not to do.
You know, build relationships, save money, and get on their feet and get a job. And that's what this shelter is all about.
Get their lives together and just figure out a plan for them to provide a better life for their family.
We got our own Mother Teresa. That's who I really compare her to. Mother Teresa, willing to help other people.
It doesn't matter why people are poor. It's what matters what we do for them to get them to be productive people in their lives. So many have lost hope, and that was my biggest dream. to make sure people had hope so they could go on with their lives.
And for decades, Mary Jo Copeland has been doing just that. But Mary Jo would be the first to tell you that her impact on the world is not measured in awards and accolades, rather by smiles and lives changed.
I've spent my life serving others. I've spent my life teaching others to serve others. And I think my legacy will be that I brought hope to thousands of people just by being faithful, by encouragement, by giving them hope that they're not alone on their journey. I made a little holy card saying, to the world you may be one person, to that person you may be the world. And if that's the legacy I can leave with this world, I want to leave it.
Mary Jo Copeland.
A big round of applause for them for being so generous and donating. Like out there crying back there. That's so wonderful.
Yeah.
And to all of you that were willing to, give up your tablets and for that donation, I commend you all. Well, that's wonderful.
Yeah.
Really,
It's
really
a
wonderful.
good way to start the morning. Thank you again
Great
for attending Midwest University, and enjoy your breakout classes. Thank you.
Yeah. Enjoy.